first part of chapter 6 is all about properties of exponents. So if you have a negative exponent, what you do is you drop the negative exponent and you move it to the denominator if it's in the numerator, or to the numerator if it's in the denominator. So in this case, for the negative 2, the 4 is in the numerator, so it's moved to 1 over 4 squared. So for any number, if you have a to the negative number, you write it as a to the n, 1 over a to the n. So if you have 1 over a to the negative n, that's in the denominator, so you need to write that in the numerator. So it's going to be a to the positive n. So here are some examples. So the first one, I have a negative exponent, so I'm going to write it as 1 over 7 squared. And you really should finish this out as 1 over 49. Okay, letter B, 11 does not have a negative exponent, so 11 stays in the numerator, but m has a negative exponent, so m to the 5th goes to the bottom as a positive exponent. Letter C, 3 has a positive, or 3 doesn't have an exponent, so it stays. X to the 4th stays in the numerator. Y to the 0, any number to the 0 power is just 1, so I don't even need to write that. And z to the negative 2 goes in the denominator as z squared. Okay, letter D, t to the 4th stays in the numerator because it does not have a negative exponent. But r has a negative exponent and it's at the bottom, it's in the denominator, so I need to put r squared in the numerator. So there's my final answer. E, this is to the 0 power, so that's just going to be 1. W to the 4th will go in the denominator because it was a negative exponent. Y to the 6th will go in the numerator because it was on the denominator as a negative exponent. And then z to the 5th still stays in the denominator because it has a positive exponent. Okay, letter F. 4 stays in the numerator. X to the 8th stays in the numerator. Y cubed needs to go to the numerator. And z to the negative 6 goes to the numerator as z to the 6th. So there's no denominator. Okay, H. H to the 5th stays in the numerator, and this goes to the denominator. So we're going to do this property, but if you have h to the 5th on the top and h to the 12th on the bottom, that's going to reduce to only having 7 on the bottom and no h's left on the top, because you're going to have h over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you can cancel 1, 2, 3, 4, 5 of them out. You're going to be left with nothing in the numerator, so it's going to be 1 over h to the 7th. That's how that property works. Okay, I want to distribute this negative 2 to each term, or each part inside here. So it's 4 to the negative 2 times x to the negative 8. So again, if it has a negative exponent, I'm going to move it and lose the negative. So I'm going to move both of these to the bottom as 4 squared. This will be x to the 8th. So I want to simplify this as 1 over 16x to the 8th. Okay, J looks super complicated, but I'm just going to distribute the negative 5s through. So it's going to be m to the positive 15, n to the negative 20, times m to the negative 18, n to the positive 6. So I can rewrite this, there's two different ways I can do this. I'm just going to rewrite these as positive exponents. So m to the 15th stays, n to the 20th goes on the bottom, m to the negative 18 goes to m to the 18 on the bottom, and then n6 stays. Now, reducing this using the quotient property is, you have 3 m's, m as in Mary, that are going to be left in the denominator. So it's going to be m cubed in the denominator. And you're going to have, there's 6 in the top, 20 on the bottom, so you're going to have 14 left on the bottom of m's. Keep a 1 on the top. So we did some of these division ones, so let's keep going with this. So if you have y to the 8th over y cubed, you're going to have 8 y's on the top, 3 y's on the bottom. There's going to be more on the top, and there's going to be 5 more. Here, there's going to be more h's left on the bottom. How many? Well, there's going to be 3 more. So there's going to be 3 left on the bottom, but none on the top, so I have to put a 1 in the numerator. You don't have to put a 1 in the denominator if you have a 1 in the denominator, but you do need to have a 1 in the numerator. So you could write 1 over 2, but that's not the same thing as 2 over 1. So you have to make sure that if you have nothing left on the top, you need to put a 1 on it. 1 there. And then C, let's look at just have a few variables going on. So look at your x's. You're going to be left with x squared on the denominator. Let's look at your y's. You're going to be left with y to the 4th in the numerator. And your z, there's nothing else with z, so you still have z to the 5th. Sometimes when you have coefficients, don't subtract the coefficients, just reduce them. So 6/18 is the same thing as 1/3. So now I have m to the 6th over m to the 5th, so there's 1 left on the top. If I have n to the 7th, they just cancel out because that would be n to the 0, and that's 1. And then I have p to the 4th. So I really could write this as mp4 over 3. I don't really need this 1 right here. It's not incorrect, but I don't really need it. Okay, E, I have a coefficient again, so let's reduce 25/15. I can divide them both by 5. So it's going to be 5/3. J's, there's more J's on the top than on the bottom, so it's going to be 4 left on the top. And the K's, I'm going to write as a positive exponent, so it's going to go K squared stays and K to the 5th, because this was a negative exponent. So now I can simplify this as 5j to the 4th over 3. K squared times k to the 5th is k to the 7th, because you add the exponents. Because this is k times k, 1, 2, 3, 4, 5. That's k to the 7th. Okay, F, I want to reduce 8/6. So I can divide those both by 2 and get 4/3. And then I'm going to have x squared, and then this x to the negative 5 is going to go to the top as x to the 5th. And my y to the 7th will cancel out because they're both the same variable, same exponent. And these two are going to flip-flop because the z to the 3rd is going to go on the top and z to the 4th is going to go on the bottom. So now let's reduce this. Or let's simplify it. So I have 4/3. Combine your x's. So that's x to the 7th, because I'm going to add those. And then the z's, there's going to be 1 z left on the bottom. Okay, so sometimes you have parentheses or you have an exponent on the outside, and you need to take each of these to that power. You need to distribute. So this one I'm going to distribute. This is going to be 3 to the 4th, g to the 4th over h to the 4th. So this is going to be 3 to the 4th is 3 times 3 times 3 times 3. So that's 81 g to the 4th over h to the 4th. Okay, B. This is 4 to the 3rd over, multiply the exponents, x to the 6th. So 4 to the 3rd is 4 times 4 times 4, which is 64 over x to the 6th. Okay, C, I got -2 to the 4th, so keep this in parentheses. Whenever you have a negative taken to the even power, it's going to be a positive. So it's -2 to the 4th, x to the 4th over y to the 4th. So this is going to be negative 2 to the fourth is 16x to the fourth over y to the fourth. Okay, D is w to the 40th over w to the 56th power, which equals 1 over w to the 16th, because there's going to be 16 extra on the bottom. E, the whole thing is taken to the 0 power, so that's just going to be 1. F is going to be 3 to the 4th times x to the 16th over y to the 4th times z to the 20th. So 3 to the 4th again is 81. So it's 81 x to the 16th over y to the 4th z to the 20th. Okay, G, I'm going to distribute first, so I get 3 to the negative 2 over 4 to the negative 2. And then since they're negative exponents, I need to move it and lose the negative, so it's 4 squared over 3 squared, which is 16/9. H, I'm going to distribute, so it's 7 to the negative 2, a to the negative 2 over m to the negative 2. So move the negative and lose it, so it's going to be m squared on the top, 7 squared on the bottom, which is 49, and a squared on the bottom. I is 2 to the negative 2, k to the negative 6, over 3 to the negative 2, k to the positive 4. So now I'm going to do all the negative exponents and make them positive. So it's going to be 3 squared on the top, 2 squared on the bottom, k to the 6 on the bottom, and k to the 4 stays where it's at. So in the end, I'm going to have 9 on the top, 4k to the 10th on the bottom, because k to the 6th times k to the 4th is k to the 10th. And scientific notation. So what I want to do is I want to divide the 9 and the 3, because there's not a part of the scientific notation. So 9 divided by 3 is 3 times. Now I'm going to subtract these, because remember scientific notation is times 10 to a positive or negative whole number. So 4 minus 12 is negative 8, so I could write this as 3 times 10 to the negative 8 power. I can write this as 2 divided by 8, so that's 1/4 or 0.25. Now I'm using decimals because scientific notation uses decimals. Times 10 to the, now I'm going to subtract the exponent, so it's negative 5. But this isn't written scientific notation because this is 0.25. So instead I want to write it as 2.5 times 10. Now I got to think about what number for the exponent will make these two equal. So this will be negative 6. So let's test it out. So this number is going to be 0.0000025, and the second number will be 1, 2, 3, 4, 5, 6. That will also have 5 zeros out front. So this is the right answer. So you can always check yourself. Okay, C, if I divide these two, 7.5 divided by 2.5 is 3 times 10 to the 12 minus negative 4 is 10 to the 16th power.